Hey students, welcome back to my channel. Okay, so last class we have discussed about the topic hybridization. Okay, so there we have discussed some importance of chemical bonding or some basics of chemical bonding, that is what is ionic bond, covalent, coordinate bond. Okay, then also we have discussed what is the hybridization. Okay, important features of hybridization, conditions of hybridization. Okay, so those students who have not seen that video, please I'll give the link in the description, go and check out. Okay, so if you see that video and understand, and this video will be the part 2 of the topic hybridization. Okay, so if you understand that, then only you can understand this one. Okay, so today we are going to discuss the types of hybridization. So as earlier in last class I have told that there are so many orbitals. Okay, one is s orbital, p orbital, d orbital. So our hybridization type will be also different. Okay, so when we are intermixing one s orbital and p orbital, we will get sp hybridization. Okay, so once a small recap I am going to do. So what do we mean by hybridization? Hybridization is nothing but intermixing of orbitals, atomic orbital which belonging to the same atom in order to get a new set of hybrid orbital which possesses equal energy, equal shape and equal size. Okay, this is about hybridization. Conditions required for hybridization is that what? Only those orbital can participate in the hybridization which are present in the valence shell or have nearly equal energy. Okay, and promotion of electrons is not necessary. It is not necessary that all the half-filled orbitals participate in the hybridization. There are some full-filled orbitals that also participate in the hybridization. Okay, features also, the number of hybrid orbitals obtained is always equals to the number of atomic orbital intermixed. Okay, these are the some things that we have discussed in last class, but today we are going to focus in the topic that is the types of hybridization. How many types of hybridization are there? So basically we will see here, we will focus on S and P. Okay, S and P. So in S, how many orbitals are there? Only one. S sub cell, only one orbital is there. But in P, how many orbitals are there? 3 orbitals are there. That is px, py, pz. Okay, so 1s, 1p can intermix, 1s, 2p can intermix, 1s, 3p can also intermix. So depending upon the number of atomic orbitals intermixing, we have so many types of what? So many varieties of hybridization. Okay, so let's start. So first hybridization that we will see is sp hybridization. Okay, sp hybridization. What are the main things? Okay, so one s orbital. Okay, we know that the shape of s orbital is spherical. Okay, one s orbital intermix with one p orbital. Let I am intermixing px. Okay, I am intermixing px. Okay, one s orbital, one p orbital will result in, as I told, number of atomic orbital intermixed is always equal to the number of hybrid orbitals obtained. So 1s, 1p will give us 2 sp hybrid orbitals. 2 sp hybrid orbitals. Okay, now what is the percentage? So here how many, see here 1s and 1p, so 50% of s character will be present. Okay, 50% of s character and 50% of p character will be present. 50% of s character and 50% of p character will be present. Okay, so its structure, they both exist as a linear. Okay, so see, this is one hybrid orbital with its smaller row. This is one hybrid orbital. Okay, and their bond angle will be what? 180 degree, or the geometry we say here as a linear. Okay, the bond angle is linear. Example, we can take all the molecules of beryllium, just like BeF2, okay, then BeH2, okay, or else we can take all the carbon compounds which are carbon-carbon triple bond, okay, which consist of carbon-carbon triple bond. So this is the example of what? sp hybridization. So once again I am saying one s orbital and one p orbital intermix in order to give two set of sp hybrid orbitals which are of equal energy, equal shape and equal size. Okay, so yeah, what is the number of percentage of character? 50% will be s character and 50% will be p character. Okay, its structure is linear and the example is BeF2, BeH2 and all the compounds which contains carbon-carbon triple bond. Okay, so now let's discuss one of its formation of BeF2 molecule or its hybridization. Okay, let's take an example BeF2. Okay, so what is the atomic number of beryllium? 4. So beryllium Be, we are discussing BeF2. Okay, the atomic number of beryllium is 4 with electronic configuration 1s2, 2s2. Okay, so the valence shell is 2 and consists of 2 electrons. Okay, so here the beryllium is the central metal atom. Okay, now how many fluorines are attached to beryllium? 2 fluorines are attached to beryllium. So here beryllium should have 2 half-filled orbitals. Okay, so during its excitation the electronic configuration will be 1s1, 2s1 and 2p1. One electron from s orbital will jump from s to p orbital. Okay, now each fluorine with atomic number 9, electronic configuration 1s2, 2s2, 2p5. Okay, the valence shell is second and the last orbital is p. How many electrons are there? 5. 1, 2, 3, 4, 5. Similarly, the second fluorine 1s2, 2s2, 2p5 consist of 5 electrons. 1, 2, 3, 4, 5. Okay, now what? One overlapping is different, as I told. Which one? This is PS and this will be PP. So the one thing we can do, that is we can go for the intermixing of two atomic orbital, that is S and P. Okay, so one S and one P is intermixed here. Okay, in case of beryllium BeF2, one S and one P is intermixed. In order we will get what? 2 sp hybrid orbitals of equal energy, equal shape and equal size. Now it contains one unpaired electron. Now the overlapping takes place between what? The last p orbital of fluorine with sp orbital of beryllium and p orbital of second fluorine with the sp hybrid orbital of beryllium. So if we go for this structure, BeF2 will be having linear structure. So as the central metal atom is beryllium Be, how many hybrid orbitals it has obtained? 2. So one with the larger lobe and smaller lobe, and the second one larger lobe, smaller lobe. Okay, now which orbital is overlapping with the hybrid orbital of beryllium? See, p orbital. Now what is the shape of p orbital? Dumbbell. Okay, so here also p orbital of what? Fluorine. P orbital of fluorine will overlap. So if you want to show the electrons, we can write like this. Now its structure is what? Linear with bond angle 180 degree. Clear? So its geometry is linear. Beryllium is the central metal atom. Now beryllium's two hybrid orbitals overlap with the what? P orbital of fluorine. Okay, so now this is the sp hybridization. So the hybridization of BeF2, what we get? That is sp hybridization. Now how much percentage of S character is present here? 50% of S character and 50% of P character. Clear? Okay, so now let's move to sp2 hybridization. Similarly, in sp2 hybridization, what will be the number of atomic orbital intermixing? sp2. So how many S, how many P? 1 S, 2 P. Okay, 1 S orbital with 2 P orbitals. So in P subcell we know there are three orbitals. Okay, one is Px, Py, Pz. Any two you can take. Okay, so I am taking one X. Okay, Px, another one Py. Okay, in result what we will get? When 1 S and 2 P are intermixed, we will get 3 sp3, sorry sp2, 3 sp2, which are of equal shape, equal size and equal energy. Clear? Now what will be the percentage of S character and P character? See how many S divided. So 33% of S character. 33% of S character and 67% of P character we find here. Clear? Now, what will be its geometry? See, 3 are there, means it will be trigonal. Okay, so one, two, three, trigonal structure. Bond angle will be 120 degree. Example, all the compounds of boron. Okay, molecules of boron. That is, for example, we can take BF3. Okay, BF3 or BH3. Okay, or also we can take the compounds of carbon, which consist of carbon-carbon double bond. Okay, which consists of carbon-carbon double bond. Okay, I am just giving you some time. Please note it down in your notes. Okay, so have you done? Okay, so now let's go for the formation of what? Let's see the hybridization of BF3. We can also go for BH3. Okay, one I am doing, another one you do it yourself. Okay, if any doubt or anything, you can write a comment. Then I will go through it and let you know. Okay, so now let's go for the hybridization of BF3. So which one is the central metal atom in case of BF3? Boron. Okay. Okay. In case of BF3. Okay. Boron is the central metal atom. Okay. Boron atomic number 5. Electronic configuration 1s2, 2s2, 2p1. Okay, so as it is attached to 3 fluorine. Okay, so we have to what? During excitations one electron will jump from S to P. So the electronic configuration will be 1s2, 2s1 and 2p2. Okay, here S with one electron and P with two electron. So we are now fluorine, each fluorine with atomic number 9, electronic configuration 1s2, 2s2, 2p5. The last orbital consists of 5 electron. Okay, similarly, next fluorine, atomic number 9, electronic configuration 1s2, 2s2, 2p5. 1, 2, 3, 4, 5. Okay, now what? We have to intermix the two atomic orbital in order to get a new set of hybrid orbital which is of equal energy, equal shape and equal size. So here, sorry, we have 3 na. So another fluorine with atomic number 9, 1s2, 2s2, 2p5. 1, 2, 3, 4, 5. Now see 3 half-filled orbitals of fluorine is present. Okay, so here we have to intermix. So we will intermix 1s and 2p. In order we will get what? 1 sp2, second sp2 and 3 sp2 hybrid orbitals which are of equal energy, equal shape and equal size. As I told, its structure will be what? Trigonal. So let's go for this structure. Central metal atom, boron. Okay. Trigonal. Okay. First hybrid orbital. Second hybrid orbital. Third hybrid orbital. Now to this hybrid orbital. Okay. Which atomic orbital is overlapping? See. Here the atomic orbital p orbital of fluorine is overlapping with the hybrid orbital sp2. Similarly, p orbital of second fluorine is overlapping with hybrid orbital of what? Boron. Similarly, in case of third fluorine also, p orbital is overlapping with the hybrid orbital of boron. So what is the shape of p orbital? Dumbbell. So this will be our overlap. P. So here no space. I am doing one smaller one. Okay. So if we want to mention the electrons, we can do like this. Clear? Now if I write here which one is which orbital, this is sp2 orbital of what? Boron. This is the p orbital of what? Fluorine. If you want to go for specific, you can write pz as well. Px, py, pz. Okay. So this is sp2. This is what? P. This is sp2 and this is p. Okay. Now what will be the bond angle? Bond angle is 120 degree. Okay. 120 degree. Okay. Note it down first. Okay. So next one is first one we have discussed about sp2. Now let's move to sp3. Okay, see I have explained about bf3. Now do it yourself, bh3, and some more molecules also I will provide you. Okay, check out the description, there you will find some more molecules so that you can do it in your home. Clear? Achha. So you will be having one doubt, ma'am. You have told easy one, BF3. Now go for carbon double bond. Don't worry. In next class we will go for that as well. Okay, we will see all the molecules: carbon single bond, carbon double bond, carbon triple bond, and also some molecules where I have told that the full-filled orbitals also participate in the what hybridization. Okay, so we will cover everything. Don't worry. So let's go for the third variety, that is sp3. Okay, sp3 is like the first two. Okay, sp1 s orbital, okay, and 3 p orbital. This is px, py, and pz. So 1s 3p. Okay, 1s 3p intermix to give how much? 4 sp3. sp3 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 and sp3. Okay, how many hybrid orbitals? 4 hybrid orbitals. Now what will be the percentage of s character and p character? 25% of s character. Okay, 25% of s character and 75% of p character. Okay, 25% of s character and 25% of p character. Now what its structure will be? Tetrahedral. How many orbitals are there? 4 orbitals. So structure will be tetrahedral. Just let me do like this. Okay. Okay, tetrahedral. Now what will be the bond angle? The bond angle is 109 degree 28 minute. 109 degree 28 minute. So everyone here example. Okay. Example, all the compounds of carbon. Okay, sp3 hybridization takes place very rarely, and that also we find in case of carbon only, when there is a carbon-carbon single bond. Okay, when there is a carbon-carbon single bond. In first part also we have discussed while seeing that why hybridization came into existence. So there we have seen in case of CH4, the hybridization was what? In case of CH4, the hybridization was sp3 hybridization. So again we will discuss the same. Okay, let's go for the hybridization of CH4. So what is the central metal atom of carbon? That is 4. Sorry, valence electrons are 4. Okay, what is the central metal atom? That is carbon. Okay, in case of CH4, the central metal atom is carbon with atomic number 6, electronic configuration 1s2, 2s2 and 2p2. Okay, in S how many electrons are there? 2 electrons. In P subcell how many electrons are there? 2 electrons. Carbon during its excitation, the electronic configuration will be 1s1, 2s1, 2p3. Okay, now okay, so now how many hydrogens are there? 4 hydrogen. Each hydrogen 1s1 with 1 electron. So as I discussed, one overlapping will be different. So which orbital of carbon intermix? S orbital and 3 p orbital of carbon atom intermix in order to give. Okay, how many hybrid orbitals? 4 hybrid orbitals. What are those? sp3, sp3, sp3 and sp3. All the 4 are what? Having equal energy, equal shape and equal size. As I told, these four hybrid orbital exist together as in which structure? Tetrahedral. Let's go for the structure. Okay, which one is the central metal atom? Carbon is the central metal atom. How many hybrid orbitals are there? Four hybrid orbitals. 1, 2, 3, 4. Okay, now which orbital, atomic orbital of hydrogen is overlapping? Which one? S. Okay, S is overlapping. So S shape is spherical. Okay, so let's go for the overlapping. Okay, so if I mention here, this is the sp3 and this is S. Here also this is the sp3s, sp3s, sp3 and s orbital. This is carbon and this is the hydrogen atom. Okay, these are the hydrogen atom. Hydrogen atoms which are s orbital overlap with the what? sp3 hybrid orbitals of carbon and give the structure like this. Okay, so all of you clear about the types of hybridization? Yes, there are some other types of hybridization as well. Because there is d orbital, so sp3d is also there, dsp3 is also there, sp3d2 is also there, d2sp3 is there. Then one question will be coming, what is this d2sp3, sp3d, sp3d? That is that have some different concept that we will cover in other part. Okay, we will discuss later on. But these three hybridization which we must understand. Okay, so hope everyone has understood this. So today we have only discussed about the types of hybridization. Okay. Now it is not possible that every time when we see a molecule, we will do all the structure, this overlapping. Okay, we cannot find like that. So if someone asks, tell me what is the hybrid, how many hybrid orbitals you will get in this molecule, then how you will calculate? Okay, so for that one formula is there. So first let me write that one. Okay, so if someone says what will be the number of hybrid orbitals obtained in this molecule, or what, tell me what is the hybridization in case of this molecule. So what you will do? So we will find the number of hybrid orbitals obtained. Once we find number of hybrid orbitals obtained, we can find the hybridization, because if the hybrid orbitals obtained is 2, then the hybridization will be obviously sp. Okay, so let the number of hybrid orbital is denoted as x. Okay, x. So the formula is x equals to half. X equals to half into first one, number of valence electron present in central metal atom, CMA, I am writing it shortly. Okay, number of valence electron, okay, electron present in central metal atom. Okay, plus next number of, okay, monovalent atom or group surrounded by central metal atom. Okay, minus if the species is a cationic species or anionic species, then charge on the polyatomic cation, charge on the polyatomic cation, plus if it is an anion, then charge on the polyatomic anion. Okay, This is the formula. What? X equals to half into number of valence electron present in central metal atom. Okay. Then number of monovalent atom or group surrounded by central metal atom. Then minus charge on the polyatomic cation plus charge on the polyatomic anion. So if we write, if you want to write it down in short, so it will be half into valence electron. Okay, I am writing it VE, valence electron, plus our monovalent atom Ma, minus charge of cation plus charge of anion. And always remember, okay, so the value for divalent atom is always equal to 0. I am writing here value of divalent atom or group is always equals to what? 0. So you will put the value 0. For monovalent, we know that 1. Okay. So clear, this is the formula to predict what? What is the number of hybrid orbitals obtained or what is hybridization. Similarly, how we can predict the shape of the molecule. Okay, how we can predict the, once we get the what number of hybrid orbital. Let I have told the number of hybrid orbital obtained is 2. Then the hybridization will be sp. Okay, if the number of hybrid orbital is obtained is 3, then the hybridization will be sp2. Similarly, 4 means sp3. Okay, so how we can predict the shape? Shape also we can predict, but that we will discuss in our next part. Okay, don't worry, you will be thinking, ma'am, you have only written the formula, but how we can identify, you didn't tell. Don't worry, okay, that also we will discuss, okay, in detail. So what in next class, what we are going to discuss? Some molecules hybridization. Okay, for example NH3. Okay, some other molecules are there. Okay, we will discuss carbons, carbon, single bond, carbons, double bond, carbons, triple bond. So we will discuss those molecules hybridization along with how to predict the what our geometry, shape as well as the hybrid orbitals and hybridization. Okay, so hope you understood today's topic, that is types of hybridization. A small recap that is I am doing. We have so many varieties of hybridization. So out of that, today we have focused only 3, that is sp, sp2, sp3. In case of sp, the number of hybrid orbitals obtained is 2. 1 s orbital and 1 p orbital intermixed to give 2 sp hybrid orbitals, where the percentage of s character is 50 and p character is 50. Okay, the structure is linear with bond angle 180 degree. Example BeH2, BeF2. Okay, or carbon triple bond. Clear? Similarly, sp2 hybridization, 1 s orbital intermixed with 2 p orbital in order to get 3 sp2 hybrid orbitals. Okay, the percentage of s character is 33 and p character is 67. So structure is trigonal with bond angle 128 degree. 120 degree. Clear? Okay. Example BF3. Okay, and BH3 carbon double bond. Clear? Then third one is sp3 hybridization, where 1 s orbital intermixed with 3 p orbital in order to get 4 sp3 hybrid orbitals. Okay, where the percentage of s character is 25 and the percentage of p character will be 75. Okay, and the structure is tetrahedral, bond angle 109 degree 28 minute. So these were the 3 types of hybridization which we have discussed in this video, and here also I have given a small hint that how we can find out the hybridization and the number of hybrid orbitals. Okay, in next video we will be continuing the next part, that is how we will in detail we will be going to discuss how to predict the hybridization and our number of hybrid orbitals and the shape of molecule. Clear? So hope you like the video and understood the concept. If you have understood, please like, share and subscribe. Okay, thank you.